Hi, everybody. Today we're going to learn about conditional probabilities. It's something we've already been talking about a little bit, but we're going to talk about how to calculate probabilities using them. All right, recall last time we were looking at whether events were independent or not. And so we call independent events are events where if I know one occurred, then it doesn't change the probability of the other. So if knowing E occurred doesn't change the probability that the other one occurs. All right, so F, the probability of F does not depend on whether E occurs or not. So it's independent of E, or vice versa. So if E is independent of F, F is also independent of E. And an example with cards is if we select a card, we put it back in the deck, shuffle it, select another card. Probabilities stay the same. In fact, every event that was in the first card picked will be independent of any event that has to do about the second card picked, because I'm starting off with the same set of circumstances each time. For the first pick and the second pick, I got my 52 cards. So dependence would be if I selected a card and then I held on to it. So this, if I replace and reshuffle, it's independent. But if I hold on to it, the set of events that can occur on the second card, now I only have 51 cards to choose from. So it's not the same. So here is the definition. The conditional probability of F given E, so these are events, and we denoted the probability of F, this slash thing here, you can think when you're reading that, this means given. So the probability of F given E is, this is the probability that F occurs given that event E occurs. And so we already used this notation last time when I was talking about independence. Let's talk about what is the probability of F given E. So what is the conditional probability of F given E? So here's what it is. If E and F are two events, then the probability that F occurs given E occurred, this is equal to the probability of both of them occurring divided by the probability of the given one is occurring. So what does that look like when I have equally likely outcomes? So I got my 51 cards that are left. Right? This is going to be the number of cards that are both in F and E divided by the number that are in E. So I count the number of both over the number in E. Okay, so let's look at our example. If the first card is a queen, but probably that the second card is a queen, right? So we call this the probability of Q2 given Q1. So, and we'll talk about how to calculate this in a bit. All right. So before we do that, let's talk about the reduced sample space for a conditional probability of F given E. So whenever I talk about given E, the reduced sample space, these are all the remaining possibilities in the experiment where E occurs. All right, right, so here I select 2 cards. The sample space for all events are the 52 cards. So when I start out, I get S. S, this is all 52 cards. So that's my sample space. Once I know my first card is a queen, my reduced sample space, let's call it SR, reduced sample space. Now this is going to be my 51 cards. And if I know it's a queen, among those 51 cards, there's only going to be 3 queens left. So those 51 cards with the 3 queens left, that is the reduced sample space. So if we want to fill in the probability of Q2 given Q1, all right, so now my reduced sample space is here. So how many ways can I get a queen on the second card? There's 3 out of the 51.